The Big Ring. While sifting through data from the Sloan Digital Sky Survey, PhD student Alexia Lopez made an astonishing discovery. 9.2 billion light-years away from us lies a massive circle of galactic clusters, so immense that it challenges our understanding of the universe. Dubbed the Big Ring, this structure boasts a diameter of 1.3 billion light-years and a circumference of 4 billion light-years, possibly making it the largest known structure in the observable universe. But there's a problem. The very existence of the Big Ring calls into question some of the most fundamental cosmological principles. To grasp why this discovery is shaking the foundations of astrophysics, we need to rewind back to the origins of the universe, the Big Bang. During the first few 100,000 years following the Big Bang, the universe was a dense sea of plasma. As waves rippled through this plasma, they created peaks and valleys in a phenomenon known as baryon acoustic oscillation, BAO. Scientists believe that the matter gathered along these primordial waves shaped the large-scale structures of the universe we see today, including the cosmic microwave background radiation patterns. However, there's a major issue. Based on our understanding of the Big Bang and current BAO models, the upper limit for cosmic structures should be around 1.2 billion light-years. This size constraint worked fine, until we began discovering structures larger than that limit, such as the Big Ring. More limit breakers. The giant arc. The oddities don't stop with the Big Ring. What makes this discovery even more peculiar is that it sits next to another massive structure that also defies cosmological limits, the giant arc. Discovered in 2021, also by Alexia Lopez, the giant arc stretches 3.3 billion light-years, larger than the Big Ring, though it doesn't form a complete circle. To put these discoveries into perspective, consider the Laniakea supercluster, the galaxy cluster where our Milky Way resides. The Laniakea supercluster is about 520 million light-years in diameter and contains an estimated 100,000 galaxies. Even so, it pales in comparison to the Big Ring and the giant arc. If the giant arc were visible to the naked eye, it would cover the space of 20 full moons side by side in the night sky. A big cosmological mystery. The discovery of the Big Ring and the giant arc raises significant questions. Their sheer size and close proximity are difficult to explain with current astrophysical models. As Alexia Lopez herself stated, both of these structures, individually and together, represent a big cosmological mystery. Their unique shapes and colossal sizes might hold important clues about the nature of the universe, but we still don't know exactly what they're telling us. Lithium and batteries. A growing concern. Batteries are crucial in powering modern society. From our phones and computers to electric cars, they make many aspects of daily life possible. However, battery production, especially the extraction of lithium, a critical component in electric vehicle (EV) batteries, has come with its own set of environmental problems. Lithium mining is far from simple. The process requires the use of chemicals like sulfuric acid and sodium hydroxide, which can wreak havoc on local ecosystems. Mining also demands huge quantities of fresh water, leading to deforestation and the poisoning of nearby water sources. While electric cars reduce emissions during use, their production, particularly the mining of lithium, can be highly polluting. Lithium is also a finite resource. As we tap into deeper and more challenging reserves, the cost and environmental toll of extraction will only rise. Alongside lithium-ion batteries, other battery types like alkaline, lead-acid, and nickel-cadmium are used worldwide, each with its own set of advantages and disadvantages. Innovations in battery technology. The search for more sustainable alternatives has become a priority. Fortunately, two teams of researchers, one in Australia and another in China, made breakthroughs in 2024 that could change the future of energy storage. In Australia, a team from RMIT, Royal Melbourne Institute of Technology, has developed a recyclable water battery. This innovative battery uses water with a bit of salt as the electrolyte, replacing the hazardous chemicals found in traditional batteries. Called an aqueous metal-ion battery, this invention could be revolutionary. Once the water-based electrolyte is depleted, it can easily be replaced, extending the battery's life indefinitely. In addition to being eco-friendly, these batteries are cheaper and safer than lithium-ion ones. Unlike lithium-ion batteries, which carry the risk of fire, water-based electrolytes don't pose a chemical pollution risk. Early prototypes have been successfully recharged at least 500 times, with over 80% capacity retention after 700 charging cycles. Meanwhile, in China, researchers from Fudan University have developed calcium-based batteries. Calcium is 2,500 times more abundant than lithium, making it a cheaper and more sustainable alternative. Although still in development, these batteries could handle 700 recharging cycles and have shown great promise as a future energy solution. The oldest galaxy in the universe in 2016, data from the Hubble Space Telescope revealed a galaxy, GNZ 11, that existed about 13.4 billion years ago, just 400 million years after the Big Bang. At the time, this made GNZ 11 the oldest known galaxy in the universe. However, with the arrival of the James Webb Space Telescope, JWST, astronomers have started to re-examine some of Hubble's findings. In January 2024, a team of researchers took a closer look at GNZ 11 with the JWST. They discovered something unexpected. The galaxy hosts the oldest black hole in the observable universe. While the existence of such an ancient black hole was surprising, what really caught the researchers' attention was its immense size, which seemed impossible for its age. According to current models of black hole formation, it should have taken about 1 billion years for this black hole to reach its current size. However, GNZ 11 existed just 400 million years after the Big Bang, suggesting that either black holes in the early universe grew much faster than we thought, or they started out larger than current models predict. Retro. The first cloned rhesus monkey cloning animals has been possible since 1996, when Dolly the sheep became the first mammal to be successfully cloned. Since then, more than 20 species, including dogs, cats, and cows, have been cloned using a method called somatic cell nuclear transfer, SCNT. However, cloning primates has always been a more challenging task. In 2018, scientists finally cloned 2 macaques using SCNT. But their real goal was to clone a rhesus monkey, a species with even closer genetic similarities to humans. After years of attempts, researchers at the University of Chinese Academy of Sciences successfully cloned the first rhesus monkey, named Retro, in 2024. The breakthrough came when researchers realized that defective placentas were causing previous failures. By growing a healthy placenta from a non-cloned monkey's cells, they were finally able to create a viable clone. While this represents a significant step forward in genetic science, the success rate remains low. Retro was the only successful clone out of 113 attempts. Tiny robots. The future of robotics. In January 2024, Washington State University's School of Mechanical and Materials Engineering created the world's smallest insect-like robots. The smallest of these, called Mini-Bug, weighs just 8 milligrams, while its larger counterpart, modeled after a water strider, weighs 55 milligrams. Despite their tiny size, these robots are incredibly fast, moving at about 6 millimeters per second. The secret behind their speed lies in the use of shape memory alloys, which allow the robots to move quickly by heating and cooling metal wires. While they may be slower than real insects, these micro-robots are much faster than any of their robotic peers. The potential uses for robots of this size are vast, ranging from robot-assisted surgery to environmental monitoring and even artificial pollination.